Good afternoon, class. We are looking at section 1.3, rates of change and behavior of graphs. We covered functions and function notation, domain and range. Rates of change and behavior of graphs is being done now. Here's the objectives. Michael?
Find the average rate of change of a function. Use a graph to determine where a function is increasing, decreasing, or constant. Use a graph to locate local maxima and local minima. Use a graph to locate the absolute maximum and the absolute minimum.
Excellent. Here's the summary for library of functions. These are elementary functions. You should be familiar. Here's a constant function, f of x or y equals b, which is a horizontal line. Domain, all real numbers, range b. Identity function, y or f of x equals x. A line that goes through the origin. Domain and range are all real numbers. By the way, I'm reminding you of the DQ, difference quotient, which is f of x plus h minus f of x over h. Square function, y equals x squared. The graph is a parabola. Domain, all real numbers. Range, 0 to infinity. Cube function, y or f of x equals x cubed. Domain and range, all real numbers. Both of them. Square root. Root functions, we have a square root of x, looking like that. Domain and range both are from 0 to infinity. Domain along the x-axis, range along the y-axis. F of x equals cube root of x, looking like that. Domain and range, all real numbers from negative to positive infinity. Reciprocal function, f of x equals 1 over x, as you can see, looks like this, and has a horizontal and vertical asymptote. X cannot be 0, y cannot be 0, and therefore both domain and range, they exclude 0. They represented in the following manner. Domain is minus infinity to 0, union 0 to infinity. Range looks the same. Ultimately, when it comes to domain and range, you try to lay it down along the x-axis to find the domain. You try to lay it down along the y-axis to find the range. Go ahead, somebody. Seth, could you read this, please?
Difference quotient, delta y over delta x is equal to f of x subscript 2 minus f of x1 over x2 minus x1 is called the average rate of change of y with respect to x over the interval x1 comma x2 and can be interpreted as the slope of the secant line PQ.
Perfect. So the bottom line is, this is the slope of a line. So the way we write them, it depends on how we look at each piece. First of all, it's always rise over run. So if this is x sub 1, this is x sub 1 and f of x sub 1. If this is x sub 2, this is x sub 2, f of x sub 2. So when we use these two pairs, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. if we look at this one, this point versus this one, and we call this A, and this distance H, this is A plus H, and this is f of A plus H minus f of A. So it's f of A plus H minus f of A over H. This, or if we use X for that, is mostly used as the DQ, difference quotient. But all of them refer to the same thing. Also, it could be that they call this one X, in which case they use this formula. Please understand, they all refer to the same thing. Could somebody read this question for us, please?
Find the average rate of change of a function. Delta y over delta x equals fb minus fa over b minus a. Find the average rate of change of a f parentheses x equals 3x squared.
Perfect. Class, we are interested in finding the average rate of change of f of x. This is red. F of x, f of b, f of a. So we want to go from 1 to 3. Therefore, according to this formula, it's f of 3 minus f of 1 over 3 minus 1. Which means we are going to replace the x with 3. We get 3 times 3 squared minus, we're going to replace the x with 1. We get minus 3 times 1 squared. The denominator is very straightforward. We get 2. (24 over 2 equals 20). From 1 to 5, the same thing. You plug in 5 and 1, so f of 5 minus f of 1 over 5 minus 1. So 3 times 5 squared minus 3 times 1 squared. Bottom is clearly 4. Three times 25, 75. Minus 3, 72 divided by 4 is 18. 1 to 7 the same way. 3 times x squared. That means 3 times 7 squared minus 3 times 1 squared. We get 24. We can plot those if need be. So the average rate of change of a function is simply rise over run. Given y equals f of x and point P with coordinates a and f of a, slope of a secant line PQ is average rate of change. With this formula, basically you're finding the slope of this line. 2 points of a curve when they're connected, it's a secant line. F of x minus f of a over x minus a. y's overrun. F of b minus f of a over b minus a. The point being, it depends what variable you're using. All of them refer to the same thing. In this format, a and this distance h, use this one. They're all the same thing. And in the previous example, we looked at a bunch of them, as you recall. This was from the previous one. Just connect 2 points and calculate their slopes. Given the function g of x equals 3x squared plus 2x minus 1, we want to find the average rate from -2 to 1. Follow the formula. F of a b minus f of a over b minus a. So f of -2. That's the concept. So this one is 3 and this one is 1, 3, and 2. 5 minus 1 is 4. So this whole thing is 4. This one is 12 minus 4 minus 1 is 7. So you have 4 minus 7 in the numerator. In the denominator, you have 1 plus 2 equals 3. And the answer is -1. Very straightforward. What is the equation of a secant line? Recall. Y minus y1 equals m times x minus x of 1. Here's the slope. All we need is a pair. For example, 1. When we put it in, we get 4, right? So the pair is 1 comma 4. So y minus 4 was -1 times x minus 1. Y is -x plus 5. Graph the function and the secant line. We will discuss the details of graphing parabolas later on, although we had seen it in intermediate algebra as well as college algebra, but for now, I just give you the graph. Points of intersection for these two functions, this one and this one. You can find them algebraically, you can find them graphically. Either way is fine. I want to explain in case how you could use a graphing calculator to find those. So here's the function and here's the secant line. I have the explanation here as to how to graph. Could somebody read this for us, please? Let's see. Did I call anybody? Michael, may I ask you?
Of course. How to graph. Step 1, enter equations into y equals area. Be sure the plots at the top window are turned off. When the equal sign is highlighted, the graph will be displayed. Note, the symbol to the far left of the equation indicates the style of graph you will see. For example, the -0 symbol will be an animated bubble with the trailing graph. To change these options, move to the far left and hit enter. With each hit, another choice will appear. If you go past an option, keep hitting enter and it will reappear. Step 2, choose the viewing window. The zoom key will let you choose various preset windows. The most common choice is number 6, Z standard, which gives you a -10, 10 by -10 or -10, 10 window. Note, this window may simply be referred to as a 10 by 10 window, implying 10 units in all directions. Step 3, hit graph to see it, the graph.
Excellent. So when you have a calculator at hand, this makes more sense to you, but the idea is this. So you put the information, we put the two equations in there, and it graphs it for us. Okay, so you press Y and you press graph. Now to find the intersection, here's the process. Pressing the calc second trace, choose intersect number 5. So you press these two. Okay, and you choose number 5. Or the guess arrow to the intersection and press enter. So first curve, second curve, guess, and it gives you the answer. Continue to the other one, and it gives you the intersection. And as you recall, we had that. So I was showing you one of them just using a calculator in case anybody is interested. Here's the function f of x equals -2x squared plus 4x minus 3. Find the average rate of change of f from -2 to 1. So according to this formula, we want f of 1 minus f of -2 over 1 minus -2. So what you're looking at here, f of 1 minus f of negative 2. This is 1, minus 2, and 4, and minus 3. They add up to negative 1. Minus 2 squared, positive 4 times negative 2, negative 8. Negative 8, negative 3, they add up to negative 19. Minus 1, minus negative 19, that means plus 19. That means plus 8, 19, so minus 1 and plus 19 is just positive 18 over 3 or 6. Find the equation of a secant line. Same formula, y minus y1 equals m times x minus x of 1. And believe it or not, we already have a pair 1, negative 1, that's a pair, because this negative 1 was f of 1. This was f of. So y minus negative 1 is m, which is 6 times x minus 1. This is y plus 1, this is 6x minus 6. Subtract the 1, and this is your line. And to graph and just put them together, and as I mentioned for now, you can even use a graphing calculator, but you should be able to graph on your own with details. All right. 3.3 rates of change and behavior of graphs. We are going to start reading, and all of this or this one refer to the same thing. Slope of a secant line or the average rate of change. Okay, if somebody could read for us again, let's see, did I call anyone? Max, could you please?
Number 1, even function. F parentheses negative x equals f parentheses x.
If I, okay, let me, this is f of negative x. This is the functional value. F of minus x equals f of x. Please go ahead.
Symmetric
WRT with respect to.
WRT
With respect
to the y-axis. Number 2, odd function. F of negative x equals negative f of x to the symmetric WRT to the origin.
to. Perfect. Go ahead, please.
For an even function, for every point, parentheses x, y, on the graph, the point parentheses negative x, y is also on the graph.
So when we look at an even function, f of minus x is f of x. And if a pair belongs to it, the opposite of x minus x with the same y also belongs to it. Go ahead, please.
For an odd function for every point, parentheses x, y on the graph, the point, parentheses, negative x, negative y, is also on the graph.
Excellent. So basically what happens is that if you're dealing with an odd function, meaning f of minus x equals minus f of x. If a pair belongs to it, such as x comma y, then minus x minus y also belongs to it because it's symmetric with respect to the origin. Go ahead, please.
A function f is increasing on an open interval 1 if if for any choice of x1 and x2, I with x1 greater than
less than
x2, we have f of x1 less than f of x2.
Perfect. So one way to look at it, it simply means when x gets larger, y gets larger. That's the meaning of it, everybody. And how about this one?
A function f is decreasing on an open interval 1 if for I for any choice of x of 1 and x of 2 in I with x of 1 less than x of 2, we have f of x of 1 greater than f of x of 2.
Perfect. What it means is this, class. When x gets larger, y gets smaller. And the last piece.
A function f is constant on an interval I if for all choices of x in I, the values f of x are equal.
Perfect. So we have an increasing case, decreasing case, and a constant. All right, we want to determine even and odd functions from the graph. Even function f of minus x is f of x symmetric with respect to the y-axis. Odd function f of minus x is minus f of x and it's symmetric with respect to the origin. For an even function, for every point on the graph, we set minus a, and y is also on the graph. For an odd function, x, y on the graph, the point minus x minus y is also on the graph. So here's an example that we want to determine whether we are dealing with odd, even, or neither. As you can see, this is symmetric with respect to the y-axis. That's an even function. It's an even function because it is symmetric with respect to the y-axis. This one is not symmetric with respect to the y-axis. So it's not even. It is not symmetric with respect to the origin. It's not odd either. So neither even nor odd, because no symmetry with respect to the y-axis or the origin. There is no symmetry. Finally, this one you can see that it's not symmetric with respect to the y-axis. However, clearly it is symmetric with respect to the origin. Therefore, it's odd function. Identify even and odd functions from an equation. All you have to do, evaluate f of minus x. Minus x. Replace the x with minus x. When you raise it to the third power, it becomes minus x cubed. And this is minus 5x. And as you can see, this is, we can take the negative out. And it's minus f of x, which is the definition of an odd function. What about g of x? Let's plug in minus x. Minus x to the second power is x squared. So it's 2x squared minus 3, which is the same as g of x, which is the definition of an even function. It's even function symmetric with respect to the y-axis. H of x. Let's replace the x with negative. We get minus x cubed multiplied by negative 4, we get 4x cubed. It's neither h of x nor minus h of x. This function is neither even nor odd. I of x is the absolute value of x. Replace the x with minus x. As you know, the absolute value of x and minus x are identical. So this is the definition of an even function. Even function symmetric with respect to the y-axis. We discussed increasing, decreasing, and a constant function. Increasing, decreasing, constant. In short, increasing looks like a line with a positive slope. Decreasing looks like a line with a negative slope. A function is a f increasing on an open interval I if for any choice of x sub 1 and x sub 2. In I, with x sub 1 less than x sub 2, we have f of x sub 1 less than f of x sub 2. The function f is decreasing on an open interval I if for any choice of x sub 1 and x sub 2. With x sub 1 less than x sub 2, we have f of x sub 1 larger than f of x sub 2. And again, what it really means in short, x gets larger, so does y. That's increasing. X gets larger, y gets smaller. That's decreasing. And in the case of a constant, nothing happens to y. A function is constant. If for all choices of x, the value of f of x remain unchanged, they are equal. Increasing, decreasing, constant. Let's look at this example. Could somebody read this for us, please?
Where is the function increasing? Where is the function decreasing? And where is the function constant?
Excellent. So the function is decreasing here. The function is increasing here. The function is constant here. The function is decreasing here. So the first part is asking for increasing from -4 to 0. Decreasing here as well as here. And the way we write it, remember the x coordinates from -6 to -4, union from 3 to 6. Make sure you're comfortable with this concept. A constant here from 0 to 3. Use a graph to locate a local max and local mean. The function is increasing and it changes to decreasing. This gives rise to a local max. Then it's decreasing and then becomes increasing. This is a local mean. A function f has a local maximum at c if there is an open interval I containing c, so that for all x not equal to c in the interval f of x is less than or equal to f of c, we call f of c a local max. Local max, looking like an arc. A function f has a local mean at c if there is an open interval I containing c, so that for all x not equal to c, f of x is larger than or equal to f of c. We call f of c a local mean. All right, formal definition here. Seth, if you could start reading for us here, please.
Local relative extreme values. Extrema is the plural of Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at a point C in an open interval, comma A, comma B, in the domain of f of C is less than f of x for all x values in the open interval.
Excellent. So as you can see, this is a local mean. This is a local max. Go ahead, please.
A local maximum is the maximum value within some open interval. Local maximum occurs at a point C in an open interval A, comma B, in the domain if f of c is greater than or equal to f of x for all x values in the open interval.
Excellent. So, local mean, local max, local mean, local max. Go ahead, please.
Absolute, global, extreme values, or extrema are either maximum or minimum points on a curve. Absolute minimum occurs at a point C if f of c is less than or equal to f of x for all x values in the domain.
So, just to understand this, local mean, local max, local mean, local max, local mean, local max, local mean. This one is also absolute minimum. Why? Because the entire interval, this is the lowest point. And this last piece,
Absolute maximum occurs at a point C if f of c is greater than or equal to f of x for all x values in the domain.
excellent. So local max, local mean, local max. This local max is also an absolute max because no other point has a larger y coordinate. So you don't have to memorize the definition, understand the concept. Peaks and valleys are max and mean, that's all. But there might be a peak that is the largest, that has the maximum y coordinate, that is absolute max, or a valley that is the smallest value when it comes to y coordinate. All right. Use a graph to locate the local extreme of part A, list the interval of which f is increasing. So f is increasing here. Okay, let's go from the decreasing, increasing, decreasing, increasing. So the increasing part is from here, -1 to 1, union 3 to infinity. You really don't want to use the endpoints, you don't use brackets. Where is the function decreasing? Here, from -infinity to the x coordinate of this point, which is -1, and from 1, union 1 to 3. At what numbers, if any, does f have a local maximum? What are local maximum? Local max, local mean, local mean. So at this point, at x equals 1, maximum is equal to 2. So there are the way you write this, it takes place at x equals 1 or at the pair 1, 2. What is the maximum value? It's the y coordinate of that pair. You really want to pay attention to this concept. What about local minimum? Here's the 2. This one takes place at x equals -1. This one takes place at 3. So we say local minimum at x equals -1, at x equals 3. So we write down this -1 has coordinates -1, 1. Here's another way of writing it. Local minimum equals 1. At -1, 1. Local and absolute minimum is 0 at 3, 0. Now, this one is the local minimum. Also, because if it's a valley, if it's a peak, it's local. Also, this is absolute. Why? No other point has a smaller y coordinate. We'll use the graph to locate the absolute max and mean, find the absolute maximum and absolute minimum if they exist. As you can see, this is a local max, this is a local mean, and this one is also an absolute max. Why? No other point has a larger y coordinate. So absolute max equals 6 at this pair. What about mean? This point is the location of absolute minimum. What is the absolute minimum? The y coordinate 1. What I want you to notice, this is a local minimum. Now, inside we have local. Outside, at the end, if there is an end, such as this one, can never be a local. For example, this one is nothing. It's not a local max because it's the end point. It could be an absolute max if it were larger than that. That's why this is absolute. It's not local. Let's look at this one. This end point is an absolute max equals 3 at pair 5, 3. This is nothing. End points can't be local. Let me just write. So this is nothing, but this is absolute. Now, what about local mean? If this wasn't a whole, that would be a local mean and absolute mean. But because there's a whole, we don't have it. No absolute mean, okay? Because there's a hole here. What about this one? This end point is nothing. This end point is the maximum. So absolute maximum is 4 at 5,4. All of this line segment, they all have the same y coordinate 1. So absolute minimum is 1 anywhere from 1 to 2, from 1 to 2. So we have infinitely many points that represent the location of absolute minimum. However, absolute minimum is equal to 1. All right, we're going to continue find the absolute max and mean if they exist. We don't have local extrema. We don't have absolute max. We have absolute mean at this point, 0 being the absolute mean, so no absolute max. Absolute minimum is equal to 0 at 0, 0. No local extreme. This one, we don't have local extreme. This could have been local mean, even absolute mean, but there is a hole. It doesn't have an absolute max or mean either because it absolute max either because it doesn't go up, because this goes up indefinitely. We don't have a point. This one, if there was no hole, this would be an absolute max, but there is a hole. We don't have an absolute max. This goes down indefinitely. We don't have an absolute mean either. So no absolute max or mean. No local extrema. But this one is a local max. Equals to what? 3 at this pair. We're going to continue on this in just a few more minutes, class. Extreme value theorem. If f is a continuous function whose domain is a closed interval. So we have a continuous function. There is no break, and it is a closed interval. Then f has an absolute max and an absolute mean. Okay, could be somewhere in between or at the endpoints. Obviously, you can see that over here we have the absolute max. There is no other point having a larger y coordinate. So absolute max is 5 at 0, 5. Here's absolute mean equals 0 at 4, 0. Remember, when we say extreme of, we mean the y coordinate of the function. Could somebody read this? We have a couple more questions to go.
Which of the following are graphs of functions? Determine whether the graph is that of a function. If it is, then use the graph to find the domain, range, any intercepts, and symmetry with respect to the x-axis, the y-axis, or the origin.
Perfect. This is not a function because it fails the VLT. Vertical line test. This is not a function. This one is a function. So if you want to know the domain, we should recognize this is your vertical asymptote. So your domain is from 2 to infinity, and 2 is not included. Range, all the real numbers from negative to positive infinity. X-intercept, 3, 0. There is no y-intercept. And this one doesn't have any symmetry, as you can see from the graph. Doesn't have symmetry with respect to the y-axis, meaning doesn't have a piece here, or with respect to the origin, so no symmetry. And here's the last question. Where is the function increasing? Where is the function decreasing? And I'm reminding you of those definitions. So decreasing, increasing, decreasing. So where is the function increasing? From negative 3 to 0. Please understand we are looking at the x coordinates along the x-axis from negative 3 to 0. Where is decreasing? The rest, meaning from this part from negative infinity to negative 3, and this part from 0 to infinity.